In a previous video, we demonstrated how to import text or an ASCII file which contained XYZ data to create a DTM for this channel, this navigation channel in a waterway. What we're going to do today is take the next step and show you how to thin a surface to make that DTM a little bit more efficient. And what thinning does is remove redundant data in flat areas or on a constant slope where the data really doesn't add much value to the DTM, but it does increase the size of the DTM and make it a little bit less efficient to work with. So let's get started. What we have is my standard InRoads dialog box. We have the existing conditions DTM that was created from that ASCII data. We do have random features, and we also do have an exterior brake line or exterior feature in that DTM, which we also demonstrated in a previous tip on how to put that into your DTM to constrain the data. However, I'm going to go and minimize this dialog box and use the standard commands that are now provided, integrated into the MicroStation environment for InRoads. So let's get started. And to evaluate this DTM a little bit, we are basically going to be using the surface commands. So these commands should all look familiar to you from the standard InRoads dialog box. If I go to surface properties, we just looked at that. We could see the random points and the exterior points that are in the DTM. If we want to look at that information in a little bit more detail, we can go to surface and we can go to feature and we can look at feature properties. And that lists all the individual features that are in the DTM. When you import spot elevations, they come in as a group. They're not individual spot elevations in the DTM. If we highlight any of these over here, we can list points on the right side of the dialog box. That gives us a textual listing of the point number, the X, the Y, and the Z that was imported in the DTM, and consequently the distance in between the points that were there, even though they're random points. So we can scroll down that list and we can start looking, and we can see, adjoining points. There is some elevation difference, not a ton of it. And what we can do is thin the DTM to remove data that really doesn't add a lot of value to the DTM. In a situation where that might arise is, as in this case, we have bathymetric or sounding information. If you have survey generated by LiDAR or maybe even aerial, you can get a lot of that really dense data that doesn't add value to the DTM, but it does slow down the system a little bit just because the DTM is bigger than necessary. Now the other way we can look at that is through visual. So we'll just do the view triangle command, show you what the triangles look like currently in this DTM. So you can see that the data is pretty dense in here. So there's a lot of observations. Everywhere there's a triangle vertice, that means there's a spot elevation in the DTM. The other way we can look at this is we can do it through a contour display. So let's do that. And we'll actually display contours twice here. This is the existing conditions DTM we have now, and we are going to thin it, and then we'll overlay that with contour display from the thin DTM so we can get a before and after picture of how things look. Now to thin this DTM, we're going to go right back to the surface commands. We're going to go to surface utilities and we're going to select the thin surface command. We have the original surface that's already created. The destination surface is the one we're going to create, and I'm just going to append that with the name thinned. And I'm going to select the boundary. In this part of the dialog box, you can select which feature should be copied from the original to the destination surface without thinning. Now, random points are really the only points that get thinned. Those are the ones I want thinned. I don't want to copy them, otherwise they'll be moved as is. And down in the lower part of the dialog box, we can select the criteria. So in this case, we can say if there's a point that's no more than half a foot delta elevation from the next adjoining point, or the adjoining point formed by a triangle leg, we want it discarded. Same thing, if there's points within, let's say 10 feet of each other, we don't want anything any denser than 10 feet. And we also want it 150 feet to define the maximum distance between points so we don't over thin it. So I'm just going to simply hit apply, create the new surface, And in the lower portion of the dialog box where we see original points and destination points, once it's done thinning, it'll tell us the delta in the point numbers that are there. And we do need to triangulate because we created a new surface. So we can see we went from almost 11,000 points to a little less than 8,000 points. So we've eliminated 20–25% of the points in that DTM, hopefully with no negative impact. Now again, this is not a huge DTM. It probably wouldn't have been necessary for this one, but we have seen DTMs where you have 1 million, 2 million, or even 5 million points in the DTM. Definitely impacts system performance. So we might as well be as efficient as we can without losing integrity of our data. And that's the big part. You have to know your data, have a little bit of an idea what the input should be in here, and move on from there. So now that we have that new DTM created, let's take a look and see what contours would look like from that thinned DTM. And I'll just load a different preference here to get some different symbology so we can see the before and after. We're displaying these all at 2 foot intervals. And if I zoom in here a little bit, we can see that the cyan is the contours off the thin DTM. The gray, light gray ones are off the original DTM. You can see it actually smoothed it out quite a bit because it's not doing quite so much interpolation on the dense data that we had. Same thing up in this area. The dark blue represents -10 or 10 feet below the water's surface elevation. In the thin DTM, this is what it looked like in the original one, and you can see these are all at elevation -10. So, just little variations would make that contour draw above or below that elevation. So things actually look a little bit better, and I don't think we've really degraded the integrity of our DTM by doing that thinning. It should just make us more efficient in our work. So that's it for this tip. Thank you for watching.